Oh, yeah.
All right. Congruent figures. Yesterday, you were supposed to do the Desmos lab activity, and if you did not, then I'm going to ask you to do that. We might do it at the end of class, I'm not sure yet. Looking at this paper says congruent figures. I want to remind you of what the word congruent means, and in terms of shapes, what it entails, okay? Because if I tell you two shapes are congruent, I'm actually giving you a lot of information secretly, okay? Y'all with me? Act like you care. Some of you I know do. Some of you are just like, eh. All right, congruent polygons have congruent corresponding parts. They're matching sides and angles. The parts that correspond between two congruent polygons have to be equal. So, for instance, looking at these two shapes right here, I'm telling you that they're congruent. That means that this has been basically carbon copied to create this. Now, they're not faced the same way, though, but they're the exact same shape, size, everything about them is the same. When you know two shapes are congruent, you can write what's called a congruence statement, which entails naming the shape. How you name the first one dictates how you have to name the second one. So if I call this A, B, C, D, then I would have to call this one M, N, P, Q. Do you see that?
Yeah.
Okay, so this is shape A, B, C, D is congruent to M, N, P, Q.
Basically what you're saying is that even if you flip it, you just have to make sure the points are the same.
You have to make sure to trace around the shape in the same order so that the parts that correspond appear in the same position. Now, once you have a congruence statement, you can actually list out all the parts that are congruent to each other. So, for instance, since A comes first, angle A would be congruent to angle M, because M comes first in the name of the second shape. So angle A is congruent to angle M.
So then it would be
Angle B is congruent to angle N. Angle C is congruent to angle P. Angle D is congruent to angle Q. Now those are the angles. Now we can list the congruent sides. Remember, sides are named by two letters. So this is where it's more helpful to look at the congruent statement. Side AB, would it be congruent to side M, N, right?
That's what it is.
AB is congruent to MN because they appear in the same order of the congruent statement. AB is first and second, MN is first and second. So side AB is congruent to side MN.
So then BC and P.
Yes. Then what?
DQ.
What
Well,
is
C.
C,
D.
D
P.
is congruent to
P.
PQ.
DA.
And then, so you might be thinking, okay, I've run out of letters, but now you can go from the last letter to the first letter, right?
You wouldn't do
So
A.
DA is congruent to QM. You could do AD if you wanted to. If you do AD, then you need to do MQ. It's the second one. Now, what you've just done summarizes what we're going to do on this sheet. These are called congruence statements. I need you to know that if I tell you two shapes are congruent, there is an entire list of parts that you can say are congruent to each other. And it all comes from me saying, hey, these two things are congruent. Okay? So now we're going to practice that. Instead of listing the entire list, now we're just going to find the ones it says in the picture. All right, so look at number 1. We have our congruent statement right here. Sometimes it's easier to look at the congruent statement instead of the picture. The picture can be deceiving. I find the congruent statement with the order of the letters easier because I can't mess that up. You know what I mean? So it says side RS is congruent to what side? Go to the congruent statement. RS is third and fourth. So what's third and fourth here? FG. All right, now it says angle D is congruent to angle D is congruent to angle P. I would like you to complete numbers 2, 3, and 4 right now.
Wait. Question.
First, because I messed up and forgot to hit record. Okay, these next 4 questions are the same thing with numbers instead of just letters, but it's the same thing.
That sounds different to me.
This is the congruent statement right here. Figure JKL is congruent to figure DEF. They want us to find X and Y. You're going to have to do a little bit of investigation here. X is here. Wait a minute, I'm trying to highlight it. X is here, Y is here. So, in order...
You dropped something.
Is it spilling?
No.
In order to find X, look at the picture. Find the side that X is next to. What side is X on? Name it.
Wait, what side?
What side is the X referring
I
to?
don't remember what it's called.
You name. Come on, y'all.
DF.
2 letters.
DF.
DF. Right?
Oh, I thought you were talking about like.
DF is X. Come to the statement. Find DF. DF. So what's it congruent to over here? I'm almost there. DF
DF
is equal to JL. Thank you. Go to JL, and JL measures 8.
inches.
Do I have to put inches?
It's a good habit to write whatever measurement it says. It also reminds you that it's not an angle, it's a length. All right, now we're going to find Y. Y is side DE.
So it's going to be
DE is equal to JK. JK measures 6.
that was pretty good.
I would like you to finish the next 3 questions. Oh, I have to repeat everything I just said. So when you go to the back, the next 2 questions are the next level of difficulty, but I want you to remember they are the same foundation that you started on the front side, okay? It's the same exact mindset, approach. The difference is there's an extra step at the end where you have to actually set 2 things equal and solve. Okay, so looking at number 9, we have these 2 shapes here. We have the congruent statement. It asks us to find X and Y. You will notice X is here and Y is here. So we're going to work on these one at a time. X is referring to what side? KL. Go to the congruent statement. KL is equal to what? EF. KL is equal to EF. What is KL? 5x. What is EF? 25. And then now you solve. 26 is the next one.
Okay,
So I would divide both sides by what? 5. What do I get?
She also told me it was multiplication.
No.
5. Wait, yeah, but like, I don't understand.
It's so easy.
No,
Well, you weren't looking when I was writing it.
I don't like, how to get KL equals
yeah, she did.
I know that they equal each other, but like,
KL equals EF. KL is the side that has 5x. EF has 25. Okay, what side has 2y?
KJ or JK.
KJ or JK. KJ is the same as
Yeah. Wait, whoa.
ED.
ED.
KJ is 2y. ED is what?
26.
Okay, and divide by 2. 2 and you get 13. Okay, please try number 10. Lower. Y is in the angle for so 5y is angle
N.
N.
And then N.
N is the second letter, so we go to angle B. So angle N is congruent to angle B, so 5y has to equal 105.
I did that. Just a 105 divided by 5. 21. Okay, I just did it this way.
All right. Go to the bottom. So this is something called a theorem. Theorems are things that can easily be proven. There's theories, right? Theorems. One of the theorems in math involves with triangles. If we know, look at the picture, if we know 2 angles of a triangle are congruent to 2 angles of another triangle, what do you think that would tell me about the remaining angle? They would also be equal. What do the angles of a triangle add up to every time? Every day, all day, every triangle, right? Okay, so if the sum is 180, and these two are equal to these two, and this sum is also 180, then by default the third angle has to be equal. So angle C, by default, would have to be congruent to angle Z. It's called third angles theorem, third angles theorem, and it's by, basically it's by process of elimination, right? Now, the bottom of this paper is a nice little preview of what's to come next week. This is called a proof. This is a 2-column proof. There are multiple types of proofs. There's paragraph proof, there's like flowchart proof, then there's 2-column proof. We are only going to do 2-column proofs. Proofs are probably everybody's least favorite part in geometry. They are the most challenging aspect to learn, and that is because some people cannot think in a proofs mindset. They just want numbers and algebra. They don't want to have to think, oh, it's this because of this reason, or it's this because of this definition. And that's what's hard. It's something that you're not used to doing. Hopefully, if you struggle with proofs, I've learned how to teach the patterns behind the proofs. So maybe if I can't teach you the proofs itself, I can teach you the patterns, and then you can still master it. Does that make sense? So you could still be good at proofs and not really understand them very well because I'm going to show you the patterns. All right? Now, we're not getting into proofs necessarily today, but this is a nice preview so you can get an idea of what's to come. All right, in a proof, there's always what's called a given, which means something you start with. You have to start with some concept, something you know. Then you have what's called the proof statement, which is your goal. okay? So we have what we know, and then we have the goal. Not trying to rhyme here. And then we have a picture, all right? The way you fill a proof in is by arguing. It's kind of like a lawyer in a courtroom, and you're trying to present your case. How do you present your case? You provide evidence, right? Like if you have a client who is being accused of, I always go to murder. I like murder docu-series. I don't know why. But anyways, if you have a client who's being accused of a crime, you would try to prove, and you're a defense lawyer, you would try to prove that the client was not there, right? Or the client had no way of being involved because they were on a plane off somewhere else. And you would have to present the ticket that they bought to be on the plane. You would have to present what's called the manifest, which is the plane's record of who actually sat on the plane, right? So stuff like that is what we're going to use here. Now, there's no murder involved. Instead, it has to do with math. Not as fun, I know. Anyways, notice the very first statement is an exact copy of what's next to the...
Please excuse the interruption, teachers. Please read your email from Mr. Sloboda about the GHP nominee meeting. All the students that's listed in that email need to meet for the meeting at 2 p.m. in the senior dining area in the cafeteria. Thank you.
Notice the very first statement is an exact copy of what's next to given. You see that? So this is where a pattern appears. Proofs always start with what's given. And the first reason is always the word given, every time. Okay? Now from here we have to actually think. This is where some people slam on the brakes. Alright, we have angle A is congruent to angle X. It's already marked. We have angle B is congruent to angle Y. It's already marked. Then the very next line is the exact same angles, but notice they changed it from congruent to equal. And notice they threw an M in there, which stands for the phrase, the measure of. This is a nitpicky part of math that drives people nuts. If you just talked about two things being congruent, you now have to talk about them being equal, because congruence means equal, right? Nitpicky. Imagine a courtroom. You have to cover every detail, right? So what's your reason? Definition of congruent angles. If I just said two angles are congruent, that means they're equal. Stay with me. All right, the next line. If you read it, it says the measure of angle A plus the measure of angle B plus the measure of angle C has to equal what? What? 180 degrees. Measure of angle X plus measure of angle Y plus measure of angle Z has to equal 180.
What's the point of early release? Is it just so that y'all can have...
We have meetings. What is the reason why we can say those three angles add to 180? It is a theorem we learned a couple weeks ago. It's called the triangle sum theorem, meaning all the angles of the triangle always add up to 180 degrees every time. Now, the next part, you have to, here's where it's like a puzzle. You have to look at it and ask yourself, what's different, what changed, what are they doing? Notice from here, we just said these things add to equal 180. They both equal 180, right? You with me? This crap adds to 180. This crap adds to 180. Then all of a sudden you have this giant equation here with this crap on the left and this crap on the right. And it says they are what? Well, that's because they both equal 180. If they both equal 180, then they both equal each other, right? This is called substitution. What they've done is they've taken the 180s out and said, okay, so then they have to equal each other because they both equal 180. So this is substitution. Now the next line is a little tricky. Look at what changed. what changed from 5 to 4? A became what? Well, do they? What did A become? What letter? Paul? Oh, Aaron? Aaron. What changed right here? A became X. What did B become? What did we say in the beginning? We said, hello, we said A is X, and we said
B is Y.
B is Y. So what did they do here?
They just switched from
They substituted those values in.
Do we need to memorize like the actual like triangle sum theorem, or we can just add the equal?
You don't have to memorize it. The good news is we're only going to do proofs for like maybe 2 days. All right, now look at the next line. We have
So like I'm sure like this is gonna be on like one of our tests about this, right?
Yeah.
Okay, so is that always gonna be in that angle? Or not angle, like
In that
order?
form?
Like
no, there's multiple types of proofs. But remember what I just said. 1, proofs is next week. 2, I'm going to show you the patterns. So if you don't learn the proofs, you can learn the patterns. Okay? This is a preview, though, of what's coming. All right, notice line 6. Look at this. It always comes from the last line. You always look back at the last line because that's what you're working with. That's what you just laid in front of the judge and the jury and said, here's my evidence. Here's my next piece of evidence, right? There's got to be a story behind it, and it has to have some type of cohesive thought process. I have all this crap here that now all of a sudden all I have is C equals Z. What do you notice up here on line 5? What do you see? What's the same? Point out to me, what do you observe? You know, like if I threw a car in front of you and I said, what do you observe? I would look for you to tell me, like, the color, how many doors it has, if it's an SUV, if it's a car, if it's a motorcycle, like, you know what I mean? So what do you see in this line?
There's more number 5 than there's number 6.
Way more. So stuff disappeared, right? Okay. Keep telling me what.
Subtraction.
Subtraction? What subtracted?
The rest of the
What?
letters.
And how do
The
you
rest
know
of the
it was
problem.
the X and the Y that disappeared? Because
They're gone.
they're gone,
I
right?
mean, what do you mean, what, guys? The rest
Well,
of
I'm trying to, you gotta understand from my position.
Yeah,
Teaching
exactly.
proofs, learning proofs is hard, teaching it is way harder. So I'm trying to ease you there. Yeah, the X and the Y's are gone. What do you know? I'm looking for you to tell me.
They got kidnapped by CBD.
Did they cancel out on both sides?
Yes, there it is. Notice there's an X on the left, and notice on the right, there's an X. Notice on the left, there's a Y. On the right, there's a Y. So you can do whatever you want to an equation, even with letters. You can come underneath and say minus angle X. It would cancel. Now, whatever you do to one side, you got to do to the other. So
But why, on step 4, why didn't they say C and Z?
you have to do it one thing at a time.
Why is it being like, because they did A and B.
Well, the idea was they needed to be able to cancel out the X and the Y. And to do that, we needed the A and the B to become X and
So why
Y.
didn't we change C to Z?
Because we don't know it. That's the goal.
Okay.
That's the goal. Remember?
If you look at the picture it gave us, then they equal. So
That's
you
the
just
goal.
change it and then cancel it. And
That's
then you wouldn't have an equation at all. And you would proof, right?
It's like if you write the definition of a word, you can't use the word in its own definition, right? If I'm trying to prove C is congruent to Z, I can't use it in my proof until the very last statement. You can't, you know C is equal to Z. You already know that. I'm showing you why. And it has to do with the math. Here we would subtract angle Y. Here subtract angle Y. And I'm left with C equals Z. And all we did was the subtraction property of equality.
Is it all we're doing?
No.
So we're not gonna have
All right.